to start, right? Yeah, good. Okay, fantastic. All right, so my name is Michael Cleef, and I'm really booming, freaking loud, and echoing at the back. Is that the same for you? Good. Okay, so hopefully they'll fix it. So my session is Why Hyper-V for VDI. This is a session that I've been doing, I did it probably last time at MMS. And what we really wanted to do with this session is talk about, some of the decisions that go into VDI and how to, sort of think about it. But one of the other things that, we wanted to really focus heavily on was performance and density. Because we came out with this big 40% higher VDI number, and a lot of people were kind of skeptical and going, oh yeah, that's Microsoft bunk, how did they actually do that? They use one of their own internal tools to make their own product look better. And the reality is we didn't. We actually used some open tools, freely available tools that you can go and use to actually benchmark your own VDI implementations. But what I'll cover off is some of the things we noticed in terms of performance. And was that in this room? Check, check. Weird. Okay. So the session objectives and takeaways. We'll cover dynamic memory and a bit of remote effects for those of you who didn't see the last session. I'll talk about, is dynamic memory just for VDI? Why VDI is actually interesting to test as a workload? And what are we now getting on core workloads in terms of server workloads? Was that announcement for real? And how do we actually go about and achieve that test? Firstly, what do we do in the test? What do we test as part of that? And how can you actually go do the same thing to get that to work? I actually find VDI a really good workload to test. Not just for the VDI's sake, just in terms of sheer performance. It's an excruciating workload. It taxes every part of your system's I/O, and you can find real areas that you can bottleneck depending on whether you architect it right or wrong. So firstly, how does SP1 change that game? Previously our guidance was add as much memory as you can because we've got really no ballooning or page sharing technology in the product to help you manage that memory more effectively or more efficiently on the hypervisor. But now we do. Basically how dynamic memory works is it does hot adds and hot removes of memory to any of the guest VMs. And we do that by being in constant communication with the VM so that we understand the VM's memory pressure and can allocate and remove based on actual demand. And we do that from a pool of memory sitting on the hypervisor host itself. So it actually supports Windows Vista with the appropriate service pack, Windows 7 with SP1, Server 2003 with the latest service pack on it as well, 2008 and 2008 R2. And of course, notably missing from here is XP because we're coming to really... Can we stop that? Can we stop whoever's doing that? Thanks. Remote effects is actually server-side graphics acceleration technology. And a few people came up after the virtualization State of the Union and were sort of asking questions, how does that work? These kind of thin clients that you've got now, this is an example of one for those of you who weren't in the Virt State of the Union session. This is a solid-state, ultra-thin client. Has no moving parts in it. It uses remote effects on an ASIC to decode the stream coming in on top of RDP and basically render it to a screen. Everything else is done at the server side, including... I'm really going to shoot that guy. Oh my God, I want to belt that guy. Anyway. When I find him... Yeah, it is fun. Shut up now. Okay, so I'm losing track of myself because I'm getting angry at that dude. So basically, we've got GPUs in the servers that are actually doing all the work. You don't have to just one GPU. You can actually have multiple GPUs. In fact, on the remote effects stands, they've actually got all of this stuff, like the thin clients. On our remote effects booth that we've got on the main TLC floor, we actually have a shuttle server sitting there. It's actually one of my shuttles. I've actually got two ATI V5800 GPUs in the server, and remote effects can actually load balance between those two GPUs and allocate work to either one of those. So it works pretty well in terms of offloading all of that work that typically the thin client would have done back at the server end. Now note here, this is only for Windows 7 Enterprise SP1 or Ultimate on Hyper-V 2008 R2 SP1. It's not for Session Host. Session Host doesn't have this capability in there yet. Certainly for the GPU rendering or the USB redirection capability. These are basically VDI scenarios only for remote effects. So what does a 40% difference in density mean? You know, it's interesting when you kind of do the numbers on this. You know, our previous reference architecture that we were doing with Dell actually had a reference architecture of about 1,000 users. It was made up of about 16 blades, which we'll talk about in just a second. Now, you know, that reference architecture that Dell used before previously ran 1,000 users across 12 blades. And it basically did it by putting 85 VMs per blade in terms of the workload. Now, when you add 40% more users to that, you now get 120 VMs per blade. And instead of now having 1,000 users, you've got 1,440 users. Now, when you work out the cost of all of that, in terms of a cost per user, okay, what does 16 blades cost in a server? Because, of course, you've got to have some infrastructure running it as well, right? Some infrastructure services. So we costed all of that up. We costed 16 blades, the 2 SANs we were using, which I'm going to mention in just a second, blade chassis, the switching in the back of the blade chassis. We included everything, 96 gig of RAM, the whole box and dice. On 1,000 users, that works out about $320 per user, because it was $320,000 worth of hardware kit. Now, of course, when you divide that now across 1,440 users, that drops the cost per user now down to $222 per user, which is significantly lower than what we had before. Now, I know what you're thinking. Where does VMware fit in this? Because VMware likes to talk about cost per user as well. You know, they did their own study. And in fact, they got $242 per user. Now, we're using login VSI for our test framework. They used whatever framework they used. I have no idea what the methodology was because they didn't really explain that very well. They used whatever hardware they wanted to use. But basically, that's their best shot. 1,280 users at that, you know, dollar per user, $242. So Hyper-V is really making strides in this area, really improving on density beyond what VMware can actually deliver. Now, when you look at the licensing comparison side by side as well, and again, I'll be very transparent about this like I was just a second ago. Ours is per device licensing, theirs is concurrent user licensing. When we compare the features of VMware View Premier Edition to Microsoft VDI Standard Suite plus the Zen plus Zen Desktop VDI Edition, $63 per device versus $133 per concurrent user. You're going, hang on a sec, that's concurrent user. Yeah, I know. Even if you've got 50% concurrency, which basically means, you know, out of 10,000 users, I only need 5,000 licenses because I'm going to get that level of concurrency, which I personally think is unrealistic. We're still cheaper. So we're really making strides in terms of cost, in terms of the hardware infrastructure required to run VDI, and also on the licensing side. But is it just for VDI? No, it's not. And in fact, when we did some work with some of our TAP customers, we found really strong success in core infrastructure workloads, web and SQL workloads especially. I mean, when I was an IT pro, you know, when I basically built new servers for customers, in many cases you overspec the box. You give it way more memory than the box actually needs. See, with dynamic memory, now I only need to give it what's required to start the machine, and then after that, dynamic memory is just going to transparently handle that for me. I don't have to think about it. It's just going to work out what the VM needs because it knows what the VM needs based on memory pressure. And in fact, some customers were seeing a fairly significant increase in density by more than 50% in some instances because now they're able to manage memory way more effectively with dynamic memory. Oops. So I'll just give you a quick look at dynamic memory for servers so you can see how that looks. So this is the same host I was running in the virtualization State of the Union. For those of you who are in the market for a laptop, this is a beautiful laptop. It's a Dell M6500, Precision M6500. It's got 16 gig of RAM. It has a 1 gig Quattro FX video card, so I can do remote effects demos. Core i7, of course, and it's got 2 drives in it. The primary drive's an SSD, secondary drive's a 7200 RPM drive. So it makes a really good demo unit for those of you who are actually interested in doing something with this. So you can see that I'm running a number of server applications as well as some client-side stuff as well. This particular app vServer is actually running Windows Server 2008. I haven't got the right service packs on it yet to be able to support dynamic memory. So at the moment, I'm assigning it statically what it actually needs to run the box. My domain controller, you'll see I'm actually starting this particular DC at 512 meg of memory and allowing it to go up as necessary. And I set a buffer on that so I can say, okay, look, I want a 30% buffer over what we see in terms of memory pressure. So if the VM actually requires 768 meg of memory to actually run, we're going to allocate a buffer of 30% on top of that in case we start some other application up so we don't run into a low memory pressure situation straight away. And I've done that with all of the other servers that I've actually got in my environment as well, including my session host box, which is delivering my sessions. So I've done the same thing. Now, for those of you who have never seen this actually in action, so this is one of my Windows 7 VMs, which I've actually started at 512 meg of memory. It will range, depending on what I'm actually doing, between 290 meg of memory and 340, 350 meg of memory just sitting there idle. I've done no optimizations to this. I've not mucked around with it at all. You can actually do some pretty good optimizations to Win 7 that will cut the footprint down actually even more. So let's go and put some pressure on it. So you saw what memory it had a second ago. It was interesting, last year when we announced this, you know, they were asking me, can you do demos of dynamic memory? And I thought, look, let's try and start a whole bunch of PowerPoints up because PowerPoints gobble up lots of memory, and let's see what happens. So of course, I'll go start some PowerPoint up, like so. We'll go start PowerPoint 2010. Good. Okay, so that should have gobbled up a lot of memory. Oh, but guess what? It didn't. So then I had to try and start videos up and more stuff just to try and put it in a situation where I could get into a low memory stress situation. And I could continue going, starting all sorts of crap up just to try and get it to push the bounds of memory. And to make the demo actually look good, what I ended up having to use was one of the tools we have internally that the test team use to stress environments. And it's a little tool which I can't give you, unfortunately, but it's called Consume. And what it does is basically a memory alloc where you can specify and say, malloc, this much memory. I want a big chunk all at once. So for this particular script that I ran, you can see I'm asking it to consume a full gig of memory all at once. Let's see what happens. So I'm going to run that test. There you can see before 232 of physical RAM. Now here we go. Let's go and see what we got. Bang. So we can see we're in a low memory pressure situation, and Hyper-V will now adjust that to get to the buffer. It's got enough memory in order to run the workload, but we're not quite at the buffer yet. So in a second, we'll start to realize that's occurred, and we'll allocate as necessary. Now, when it comes to releasing the memory, I'm going to simply just hit enter to get rid of it, that app. You see it now drop back to 406 meg of memory in terms of memory pressure. Now, you see on the VM, it's still saying it's actually got allocated 1,500 meg of memory. Over a period of time, the hypervisor will determine, it has a deterministic algorithm based on the memory pressure of the server and also a set time period where it actually works out and goes, okay, you don't actually need that amount of memory anymore. I'm going to claim that back to the pool. So we actually pull all of the memory back to the pool to allocate out to other VMs as necessary. Now, the thing I find funny is some of VMware's claims around this. So as I switch back to my client, I'm going to pull up one of their blogs. This line made me laugh. Dynamic memory improves their density by 40% over the previous version. Yeah, we know. It's an improvement but won't be able to catch up, which showed in Tanager's group testing. By the way, just for those of you who don't know who Tanager Group is, it's staffed by a bunch of ex-VMware people. Wonder why they used them. An overall density of 2 to 1. Well, that's because they didn't actually test dynamic memory. They tested the previous version. You see the signs of that effect in painfully slow 2-second max response times that Microsoft ran to justify their VDI claim. They're actually linking to an article that I wrote on the Windows Server Virtualization blog. We're going to discuss that in just a second. But basically, they're also making some other interesting claims here. Since Microsoft hasn't invented hot remove, we can only ratchet up the RAM, we can't come back down, which is an out-and-out bunch of bunk. We can absolutely pull the memory back. We have no trouble pulling the memory back to the pool, so we can dynamically add and remove as required. So let's go and answer some of those claims in terms of some of the testing we did. So for those of you first up who don't actually understand what VDI is anyway, VDI is basically the concept of having multiple individual Windows 7 VMs, or in some cases, if you want to use Windows XP, you can, but I kind of think you're crazy because it doesn't actually perform very well. We'll discuss that in my next session, which I think is on Wednesday. I'm going to discuss some of the testing we did with XP, as well as Win 7, and why Windows 7 is actually the better platform to be testing with. But basically, it's this concept of hosting VMs on a hypervisor and brokering a connection to that VM as necessary. But why is it so interesting to test? So server virtualization has been very mature. People have got a lot of success with it. They've been able to consolidate a number of servers and really reap the rewards of an increased return on investment with very, very measurable TCO gains. Very, very measurable. What we see in terms of IDC data is 81% of customers virtualize anywhere between 1 and 14 guests. That's good, but VDI stresses it a heck of a lot more. Right now, it's difficult to project ROI gains. Nobody's really had it long enough to be able to measure their return on investment over the extended period of time it takes to recover such a significant capital outlay, such as for VDI. Typically, in order just to make it make sense, you need to be virtualizing anywhere between 30 to 120 guests per server, just so that you can get the economies of scale down to a point where it actually works. Disk I/O is hit especially hard in VDI. It's the first bottleneck you're going to hit. If I was to put them in order, it's disk I/O first, then you hit memory pressure as a ceiling. I don't call that a performance constraint, it's just a pressure constraint. And then finally after that, processor. And when you look at the attributes of a VDI platform, there's a lot of attributes you need to be thinking about. The reliability of the platform, the robustness, how cost effective is the platform in terms of licensing, as well as the hardware investment you're going to have to make on VDI. Performance, density, redundancy, security, ease of configuration, and ease of management. It's an interesting point that Hyper-V straight out of the box doesn't require any specific performance tuning or tweaks in order to make it work. It just works straight out of the box. You don't have to muck around with the scheduler. You don't have to change HIMP values. You don't have to change anything. It just works. When the VM starts, it just works. You don't have to wait for memory techniques to kick in order to get your memory to a point where you're now ready to go. The time to value is very, very fast with Hyper-V. So today we're going to focus on high performance and density. Now, caveats to this. There's a lot of caveats, and I will share these slides. I was just lazy and didn't upload them yet to ComNet, but I promise that I will. So you don't need to necessarily take photos, unless you're from VMware, because I do have VMware spies in my sessions. Project VRC is the tool we used. Project VRC and Login VSI is the tool we used for all of this testing. In the testing we used, we actually started the testing around about this time last year. At that time, the version that was out of Login VSI was 2.1.2. They now have a version 3 of this, which actually whacks the proc a bit harder, as well as the disk a little harder as well. Consequently, they feel a little happier with the benchmark that you'll get out of it as being a little better representative of the typical user case profile. But within this tool, it has different profiles. It has a low-end worker, a medium-end worker, a high-end worker, and then within each of those segments, it has flash on and off, because Adobe Flash is a significant killer of density, specifically in the proc side. I found it very, very proc heavy when we did flash testing. But this was the workload we used, and this tool basically runs a bunch of automation that does things like starts Outlook, starts Word, goes and edits a document, then switches over to a PDF document, prints out a PDF. It tries to simulate a user workload, including going to the web, running some Flash, doing a whole bunch of different tasks to try and simulate what would it look like if I had 1,500 users all going at once on a system. What would that performance actually look like and actually be? Now, what we actually used for our testing, the first up, we actually used a DL380G6 server just because we had it lying around at the time, and we wanted to see what that profile would look like. But Dell were actually planning on giving us a whole bunch of hardware to play with, which was very generous of them, and I thanked them for that. Basically, we started with the DL380G6, then we moved to Dell M610 blades. Notice on that HP DL380 slot, we actually used a 42-disk iSCSI target. It was very basic. There was no rocket science to this. It was just a 1 gig interface between the DL380 and the iSCSI storage target, and just a bunch of storage arrays sitting on the back, just so that we could mitigate oversubscription of the disk, so we could truly identify how is dynamic memory performing, because that was our end goal. How is dynamic memory actually performing, and what difference is it actually making in terms of our density? The next lot of tests after that was the Dell M610 blade, which we're using the newer Westmere procs, dual hex core hyper-threaded procs, with 2 procs in each blade. You end up with about 24 threads per blade to play with. So there's plenty of go there. 96 gig of RAM per blade, and we actually had 2 Equalogic SANs. One was a 16-disk SAS SAN, and the other one was a 8-disk SSD SAN. So we played with those 2 SANs as well. And again, our goal, how does dynamic memory influence the performance and scale of VDI? Now, like I mentioned, disk I/O is the first thing you hit. Second thing's memory pressure. Third thing after that is the proc, in that order. So you've got to really solve those one after the other. Now, in terms of your rule of thumb here, we recommend if you're just trying to play around with this on old servers, you're not going to get great density. Any of the older procs pre-Nehalem or pre the Opteron procs with either, now what does AMD call it? NPT, or Rapid Virtualization Indexing. Anything before that, you're not going to get great density. You need to be using Nehalem or higher. Nehalem, Westmere EX, or whatever they've got now, makes a really significant difference in terms of density. For those of you who also didn't know, we made some changes to our clustering story. Previously, I think we would only support around about 80 VMs per cluster node. Now what we're actually saying is we will support 1,000 VMs across your cluster. And of course, a cluster can go as big as 16 nodes. So no one server can be higher than 384 VMs, though. So there's a rule of thumb there, but we'll support 1,000 VMs across however many cluster nodes you have. We also made some changes in terms of the support for VMs per core. Although in our case, we actually measure the logical proc, not really the core. So if you look at a hyper-threaded processor, there's actually 2 threads or 2 logical procs that run across each core. We actually count each one of those from a support standpoint. So we actually now support 12 VMs per logical proc. It's, again, not a limitation of the system at all. It's just simply what we've tested and what we're willing to say, yeah, we'll absolutely support. More often than not, most customers end up with around about 5 to 6 VMs per core. That's just what people end up settling on in a production scenario. Like I mentioned, disk performance is the most critical factor in achieving density. Look, there's various different approaches to solving this problem. If you were looking about this time last year, the approach you basically took was how many disks, how many spindles, how many IOPS can I actually get funneling out of this SAN? Then I started talking to NetApp, and NetApp were basically saying to me, you know what, we can just dedupe the whole VM across however many VMs you actually have on the SAN, And then when we work out that there's 80% or so that's all the same, we load that into Flash and feed that as really fast I/O out in the wire. So NetApp was solving it with basically dedupe and caching to make sure that they've got plenty of I/O out. And there's been some other approaches too. The Fusion I/O cards, fantastic. What that basically is solid state storage sitting on a PCI card going into your server. You put your gold master image on that, and you feed out from that, and you get really fast I/O. So lots of ways of skinning this cat. In our case, we actually split the I/O because we were using Citrix, and we'll discuss that in just a second. Now, if you've got low complexity requirements, you can think about cheaper direct attached storage. Please do not use RAID 5. It's got great read performance, but really crappy write performance. At least look at RAID 0+1 if you're going to go down that path. It's a cheaper way of doing it, and you'll definitely get the results. And in fact, that's what we used on our 42-disk array. We just basically used RAID 0+1. The other thing you should consider first up, though, before you even get to here is, have I really exhausted whether I can solve this problem with RDS? In my session that I'm going to talk about on Wednesday, I'm going to go into a lot of detail on why you should actually think about RDS first and how that actually solves the majority of the scenarios that you would look at VDI for, such that you'll get to probably an 80-20 split of sessions versus VDI for those people who are going down this path. This was my previous guidance, static memory, because that's all we had. We didn't have pre-SP1 anything other than this. How much can I get in? Squeeze as much as I can. We love UCS for that, Cisco UCS, because you can squeeze in stupid amounts of memory at a pretty low cost and really get a big, big pool of memory on the box. With dynamic memory, it changes it all. Less is more. You now don't have to statically allocate 1 gig of RAM. We actually support 512 meg startups. Now, we're not saying you have to start at 512. We're saying you have the choice of starting at 512. Like in my example that I showed before, I had a Windows 7 VM even when I'm running PowerPoint and a bunch of other applications, I'm not even getting to the top end of 512 meg of memory. If you've got lower-end task workers who are starting the same 2 apps up every day, where basically most of the work's actually being done at the back end, 512 meg is absolutely fine. But if you've got heavier-end knowledge workers, you may not want to start at 512 meg of memory. You may want to start at, say, 768 or even a gig of memory and allow dynamic memory to take care of the rest. But it will tune itself. Most of all, you don't have to weaken Windows 7 security in order to get the best density. Again, in that blog, they reckon that we're calling them out around security. The point was, if you turn off ASLR on a VMware host, you actually get 16% better density, but you compromise security for that. What's the trade-off going to be? If you use Hyper-V, you don't have to turn it off in order to get 16% better density, because Hyper-V was actually designed to work with dynamic memory. Sorry, Hyper-V was actually designed to work with dynamic memory and Windows 7 Service Pack 1 with ASLR all switched on. You don't have to change or compromise security in order to get that actually to work. So this was the first result of the test. And I'll explain what this actually means. This is a graph that Login VSI actually generates at the end of the test. So it iterates through. It starts up one session after the other. You can choose the interval time between the starts. You can say every 30 seconds, start up a new session. Every 30 seconds, start up another one. Or 60 seconds. I think we started ours every 60 seconds. What it does is then measures response time for each of the things that it actually starts up. So it goes, okay, I just started Word. How long did that take? And it checks for each VM that it actually starts up and starts to monitor. And as it starts to get to the end, the first one that it started now just loops around and continues on. And they just keep looping and looping and looping until the last one is actually executed and completes, and then it starts to log them off. They've got this indicator as part of the Login VSI workload called VSI max. And basically what it represents is what density can you get to before you start to really cap out the system. The Login Consultants method actually measures if you start to hit 2,000 milliseconds more than 3 times in a test pass, on average, you're basically maxed at that particular point where you started to hit that number. So they call VSI max, say, at 70 machines, because your total system performance can't actually keep up with that. Now, notice at the end here, there's this odd spike. So I'll explain the lines. The red line is the maximum response at a particular point, not on average, but a particular VM hit it. The blue line represents the on-average performance across the test load, and the green line represents the minimum, or the fastest. The blue line is what's actually significant. Now notice at the end, the blue and the green line actually tip off, and then the red line strangely spikes. Now when we went through our performance counters for this, we couldn't understand this spike. We couldn't correlate it to anything. We went through our disk logs, we went through our proc, we went through everything that we could try and see to see why did we get this little tick at the end. We talked to the logging consultants guys. They said it's actually an aberration when you run the results through Excel and you get Excel to generate the chart when you didn't hit VSI max. So it's not actually hitting 2,000 milliseconds at all in the test. We just noticed why is this occurring? And they said it's actually not correct. It's actually just an aberration. Again, VMware called me on that because I actually posted this graph on the virtualization blog, and they reckoned that was the result for the 2,000 milliseconds excruciating performance, which actually really wasn't at all. Okay, so when I actually look at the performance result of that, and that was actually a 64-bit Windows 7 workload, you see dynamic memory kicking in during the workload's execution. You see at the top end of the test, we ended up with probably about 4 to 5% free memory at the top end of the test. And then it starts to deallocate at the end of the test when the sessions are actually starting to log off. The parent partition processor is the red line, and it's basically just the parent partition telling us how it's coping in managing that many child VMs sitting on top of it. The green line represents the disk queue length. This was a big concern for me because I was concerned we were going to run out of disk I/O. Now, we have a 42-disk SAN, which means our disk queue length cannot exceed 42. At no point did we hit 42 in terms of our disk queue length. I think we capped it around about 24. So it basically was saying you are keeping up absolutely no problems with the amount of resources you have in the box. Now, when I found out from my team that they were using Windows 7 64-bit, I was kind of concerned. I said to them, why are you using 64-bit? They said, that's because there was a policy in the lab that you now manage. We had a policy around everything 64-bit. Now, for those of you who know about 64-bit, will know that it actually allocates more memory than 32-bit. So I actually asked them to rerun the test with 32-bit. So now we're actually using a different test result tool. So you can see the graph on the left-hand side is actually in gradients of 500. So it goes 500, 1,000, 1,500, 2,000. So this is now on the Dell M610 blade with the Equalogic SAS SAN, just with the 16 disks in it. So we were not using the SSD SAN yet. Again, VSI max was never reached. Our blue average line just tweaked over 1,000 milliseconds. The red line hit 1,500 at the top end of the test. We're within the parameter of an acceptable response according to the login VSI test. Again, roaming profiles not implemented in this test at all, but this is 32-bit. What was interesting to me is the memory difference. So before, because each VM was sitting higher in its actual allocation, so we're starting it at 512 meg of memory, it was actually sitting at about 400 and something meg of memory. Now you notice with 32-bit that was actually running on this machine, we're sitting at around about 300, 350, anywhere in between there before we start to run apps. So we can actually run PowerPoint and Excel and a whole bunch of stuff without really needing a lot more memory. And in fact, during this test, you see the red line here represents one of those VMs during the test pass. And you see where it actually started to invoke some workload. It actually only hit 540 meg of memory. So throughout the test, even though it's running PowerPoint, Excel, everything concurrently all at the same time, we're actually still sitting on a fairly low load in terms of memory. So our working set still stayed great. We still had 30 gigs free in the server without having any sort of pressure on the server at all. So plenty of RAM. Again, with this particular test, we see this little aberration again at the end, same odd spike. So when we reran the test, and what you'll find if you go and rerun the test, is you'll start to see different results each time you run the test. It's just a product of running that many VMs all concurrently at the same time. You are going to see slightly different results during the test. So you see some spikiness there, and in fact, this particular test that we ran, we saw some interesting spikes. We couldn't work out why they were there. 120 VMs, 32-bit guests, it should have been okay. I was really concerned why we saw these two spikes and tried to understand why. Now, when we went through the performance counters later on, sorry, this wasn't 32-bit, this was 64-bit. When we went through the performance counters later on, notice these two spikes here. This was disk queue length. Now, bear in mind, we're running 120 VMs across 16 disks. There is a significant oversubscription there. We're not using any caching, we're not using Fusion I/O or anything like that in order to manage the performance during the test. It really pointed to the fact that when disk I/O is having trouble keeping up, everything starts to crash and fail. So you see here, 16 disks in the SAN. We should have never gone above 16 if we were going to be able to sustain the workload. And you can see, we significantly had trouble with the disks that we were actually running. That had me concerned when we moved to this. So this was the blade chassis that Dell gave us, 16 blades and 2 SANs. One SAN was the SSD SAN, the other SAN was the SAS SAN. Now, I was starting to think, man, we're not going to be able to run 1,000 VMs across these two SANs. Dell didn't give us the same SANs that they actually used in their original cut of the reference architecture. So what we did was we used Citrix Zen Desktop 4 at the time to help manage this. Zen Desktop 4 has this capability called provisioning services. For those of you who understand how AppV works, this will make sense. What provisioning services actually does is it streams the VMs in dynamically to the target VM. Sorry, it streams the blocks of the operating system dynamically into the target VM in a similar way to the way AppV streams a package from a management server into a client into a little local cache. Same way provisioning services works. Now, what it gave us the ability to do was connect a provisioning services server up to the SSD SAN, so we got really great read performance out of that SSD SAN into the provisioning services blade, and then the provisioning services blade would actually deploy images or on-demand operating system bits to each of the 120 VMs in each of those blades. On each of those blades, we actually had it hooked up to a LUN on the SAS SAN that it could actually write its little write cache out to in a similar style, again, to the way AppV actually works. So that was kind of our idea how we could actually manage our disk I/O performance. And this was the test. So you see, during the test, again, VSI max was never reached. Yeah, we saw some spikiness on the max end line, but hey, we're running, a significant number of VMs here. This was 1,000 VMs on this particular test. 8 Dell blades running against 2 SANs. Heavy oversubscription in every way, but again, Hyper-V had no trouble in keeping up with that load. And when I actually looked at one of the blade's performance charts, the thing that was really concerning me the most, which was disk queue length, we never even got beyond 1, let alone being worried about 16. So we really managed that effectively by splitting our read and write I/Os out into 2 separate SANs and actually using provisioning services in order to actually manage that environment effectively. This was one test where we implemented roaming profiles. How many of you have hated roaming profiles your whole life? Yeah, it sucks. It absolutely sucks. It doesn't perform very well. It really caused a performance impact the moment we switched it on. What we tried to do was simulate a typical roaming profile server. We just had a standard, I think in this case we used an R710 Dell box with some storage in it. We simulated a couple of switches, hops between the Dell blade chassis and that particular server, again, to try and simulate a typical corporate environment. That's what we got. So you can see we actually did hit the blue line onto the 2,000 milliseconds, and the test was considered failed at around about 90 VMs. We couldn't actually sustain the load because roaming profiles was really letting us down. In every other way, we had the best environment. We used provisioning services, we used dynamic memory, we used the Aqualogic SANs, we used the best blades. All we did was switch on roaming profiles. So it can definitely cause an impact in density. Now again, because in a VDI environment, you're definitely going to have to manage user state, especially if you're going in a pooled environment. Definitely recommend you look at some of the third-party guys like, say, AppSense, who's one of our platinum sponsors this year. Go and have a chat to them about how you can not just solve the VDI challenges in terms of performance as well as how to manage users, but right across your clients as well. So what else affects density? Poor storage architecture is the #1 candidate. Antivirus is a big killer. In fact, I talked to one of our Forefront guys last week, and we together kind of came up with some recommendations about how you can approach tuning antivirus to actually perform a lot better in a VDI environment, because it absolutely will kill your performance. I'm going to mention that in the next session. Slow networking to core infrastructure services. When we started playing around with NIC offloading, like the iSCSI offloading capabilities and TCP offloading, we saw a big drop in performance. You've got to make sure all that stuff's switched on, latest drivers, latest firmware. Just make sure all of that stuff's right up to date. So the conclusion, Hyper-V definitely delivers high scale at low cost. We're really challenging the #1 there. And we're really making some very strong inroads into how you can get better density and better performance. And the good thing is the total stack cost, even in terms of licensing, is now cheaper than VMware as well. So I'd encourage you to do a proof of concept. Do a shootout. Do a shootout for yourself and just have a look at, say, for example, especially have a look at the disk I/O characteristics of Hyper-V. I think you're going to be very surprised on how good the native performance is, especially around disk I/O of Hyper-V, compared to others. So next steps, check out Citrix and Microsoft.com or Citrix.com Zen Desktop for more information. And with that, we are done. Complete an eval, you can win stuff. Thank you very much for coming. Just questions in the mic. Can we have the microphones on, please? I can't hear you very well. Can you just go back to the mic? And I'm sure he'll turn it on.
Hello?
There we go.
Awesome. So, Exchange 2010's got DAG built into it, database availability groups.
Yep.
SQL Denali has got always on availability groups.
Yep.
It's part of 2008 R2.
Mm-hmm.
Is Microsoft considering putting that kind of technology in for the local storage? So you can deploy say a Hyper-V box out by itself and have it replicate to another local storage box for backup.
We're not talking about what we're doing next. So I would love to answer your question, but that's futures stuff, and we're not ready to discuss futures yet. Not the answer you wanted.
So
God, I would love to tell you too, because I've seen it, and it's awesome, but can't tell you about it.
All right.
Hey, Michael. Can you talk about what part of roaming profile behavior hammered the performance? So in what was it doing when it was doing that?
Well, because roaming profiles and folder redirection is basically, folder redirection, backwards and forwards. Every time it has to pull down the profile, it just causes a big impact. So what we noticed, every time it had to round trip backwards and forwards, it was just slow. It was not really built to scale like this. It was built for an age where you had a one-to-one relationship between you and a PC. Even Citrix adds on top of roaming profiles, but what they do is they separate out, make it a little more asynchronous, so that you don't literally, have log-on, script execution, group policy. Your profile comes down, then you finally get your desktop. They actually split out some of those actions, so some of those things come separately as you're actually required, right? So you actually get better performance in that way. Any other questions? Nope, with that we're done. Thank you very much for coming. Come to my other session.
I got one more for you.
Oh, okay.
Most of your demos up there were with Windows 7. How much behavioral difference should you be expecting if the virtualization target is itself a 2008 Server R2 instance?
Sorry, I'm not sure I understand the question.
Well, for example, in one of the virtualization environments that we're pushing, 100 plus of them, are actually to support developer VMs, so that we can roll them back to clean instances and other things very quickly.
Yeah.
And I'm trying to understand what's the difference in profile expectations that I should have, where what's the OS in the virtualized environment is an instance of Windows Server instead of Windows 7.
Yeah, don't really know the answer to that one. Because I still don't understand the question, really. You're asking me what the difference in density is going to be for server versus client?
Yes, as well as what's a minimum reasonable startup footprint to expect.
Right. Okay. So the servers, like with the client, it's going to be a real depends on thing. How many apps do you have that you're going to run concurrently? You really need to plan that out, just like you would with any other hypervisor, that basically, pulls memory like this. How many VMs do I reasonably expect, and how much spare capacity do I want to leave so I don't fall off a cliff if I actually exhaust memory? It's going to be a real planned effort. What I found in practice with my domain controllers, anywhere between 768 to a gig of memory, although I don't believe we have the same support limit for server that we have for client on startup of the VM, like 512 meg startup. I think with servers, you still have to start at 1 gig. And then dynamic memory will handle it from then on. Does that make sense?
Yeah, I'm guessing that we're going to have to.
We can chat offline.
Okay.
Yep. Any other questions? Nope. Okay. Thank you so much for coming. Come to my session on Wednesday and we'll talk more about this.